Hey folks, welcome to episode 3 of the Nats FM podcast, which is a podcast brought to you by the stewards of the Nats IO project. So how are you doing, Byron? You good?
I'm doing great. How have you been?
I am superb. I've got the seasonal flu, I've got pain meds, coffee, energy drinks, so I'm wonderful.
Wonderful, yeah. Beer bottles getting thrown at you, you know.
Yeah, it's just another day in the UK. You know, what a life. Oh, sigh. Anyway, there we go. So, you're going to be the victim, I think, for episode 3. You are the man who can with all the experience. So, let's talk about the HTTP-shaped hammer and how everybody tries to fashion the problem space into something. I don't know whether it's easily grokkable, but if we wind the clock all the way back to 1989, and we have Tim Berners-Lee working at CERN. Let's do this HTTP thing. Great. And I've got to be honest, we're in 2023, I think, right? And it doesn't feel like the world's really moved along. You know, we had like 15, 20 years of wonderful stability, and then HTTP2 came along from there was this SPDY project, and then HTTP3 now looking over quick, but I don't think any of that has kind of made it into, and you know, call me an idiot, mainstream dev thinking. Most people just think about the verbs, the CRUD: create, read, update, delete, patch, post, whatever. And then,
and what's worse is that people learn those verbs and rest as a concept. They think JSON over HTTP is rest, and that's also incorrect.
Yeah. Wow, we can get into that whole hypermedia debate.
That might be something else, yeah.
Yeah, anybody listening to this on a podcast is going to like throw themselves out in front of a truck, I think, if we get into that one. Maybe that's an episode 4 one. But yeah, wow. So we've really abused the whole set of mechanisms that the kind of Tim initially provided. But I think the main issue that we see, and again, maybe I see and nobody else does, but it's how we translate the process of inter-process communication. So how we get components communicating, or my browser to an API, typically HTTP. Yeah, gRPC's around, but I think we could safely say 75-80% of the web is wired up on HTTP calls. And then we start talking about this kind of like degranularization, smaller components, microservices, whatever you want to call it. We take logic, we put them into tiny blobs, and then somehow we've got to tie those blobs together. And what do people do? Oh, well, we'll stick a HTTP proxy in front of everything. And we go, oh dear. So HTTP hammers.
Yes. And we can't, I think I was reflecting on this before, and we were talking about this, and I think you can't blame people because HTTP is ubiquitous. It's what we know. It's how we interact with the web. But the thing is, and you bring up Tim Berners-Lee, which is great. It's just like HTTP was designed as a protocol to serve the web, to serve up web pages, to like share information. It was never designed to be, inter-process communication, really. So. And yet it's a protocol that like people know and have adopted, and it's just like, well, let's just run with it, really not giving it a second thought of saying, is this ideal? Is this optimized? Are all the semantics of HTTP and the specifications, are those even relevant when you're having two services trying to talk to one another? It's very relevant for browsers and other web clients, but not so much with actual inter-service communication.
Yeah,
so,
and at that system level, I mean, just that whole inter-service and even intra-service, you could talk about something simple like schema, whether it's JSON schema, XML. I mean, who cares really, whatever it is, but it just wasn't designed for the world that we're in today. And it served a wonderful purpose. And that's the other thing. We could come off this like a pair of jerks going, oh, HTTP. And that's not the case. But as we begin to solve more complex problems in distributed systems, HTTP is great as like a sentinel mechanism that everybody understands at the edge. But then that's, I guess, where we are with microservices. There's a listener, something on the edge that says, hey, I'll take this call. And then what happens? And what happens is just a mystery, I think. No, it's not really a mystery, but we've got lots of different ways of solving that particular problem. And I think the nice thing is, it's a bit like I do this all the time, but it's like that South Park episode. the underpants names, the underpants names, steal underpants, something happens, and then they make money. In our case, we assemble the components, something happens, and we get a service call. And it's that whole middle bit. So we can use NATs to build this system of components that can cross communicate. And then somehow we have to decouple that with HTTP at the front door.
Mm-hmm.
Yeah, that's an interesting one. So I guess without trying to boil a whole ocean with like a zip lighter. Do you have zip lighters in the US? Zip?
We do.
Oh,
we do.
Cool. Okay.
Mm-hmm.
They probably come from the US. I'm just really naive. So yeah. So yeah, like holding a Zippo lighter up and trying to boil the ocean. Let's maybe not do that. But maybe there's a gradual way we can explore this space. So if you're moving today from monoliths and you're thinking, I want to break my application down into usable chunks, and I'm thinking about maybe not even microservices, let's call them macro services, whatever. What would, off the top of your head, be some of the easiest ways to decouple HTTP at the front door and then wire it up to NATs on the back end?
Mm-hmm. Yeah, you made a good call out. And I know we talk about edge a lot, but the browser is just another edge. It's an interface to users interacting, engaging with web pages and things like that. So that's definitely an appropriate use of that of an edge. And I think and there's edges everywhere. A database is an edge. It's a terminal. Input and output sync that database might be doing, but from an application standpoint, you're interacting with these other interfaces, devices, what have you. But the question is, how do you compose and how do you have your services actually communicate among all of them? And how do messages flow across them until they hit one of those kind of edge points? So we touched on this last week, which was sort of really calling out the fact that if you have a monolith and you're doing, method invocations, things like that, if you try to go, let's say, directly to microservices because it's a trendy thing, which none of us advocate for, unless you have a purpose to do it. But we talked about the shift to a modular monolith, and we said you still need boundaries. You still need to identify the boundaries within your source code, whatever your mechanism of modularization is, classes, packages, what have you. You have to do that first. And then the question becomes, how do those modules actually interact with one another? And that's when you essentially create an API layer. You're saying, these are the public set of methods, let's say, or public interface that you use for those modules to interact. And then we said, well, what if there's a future state where you may need to carve out one of those modules to your point, a macro service of some kind. You can have one giant, and you hear this all the time in when the Ruby community and the Python community, when they started kind of, let's say 10, 15 years ago, when there was a shift in an adoption of microservices, or people started needing to scale more. They're like, we still want to have our nice monolith because that exist. That's where all the business logic is. But you start, adding or carving off little pieces or building net new services that always have to talk back to this monolith. And so in many cases, beyond, a certain level of scale or performance, and you don't go to microservices again for the fun of it. There are various reasons why you might need to, because you might need to scale a bit of functionality separately, independently from the rest of the thing. And so if you're accepting of the fact that your system, your application is going to have to evolve and may need to be broken up in some form or fashion, we had talked about last week to say, well, if you just start with, NATs as a communication mechanism between all of your components right out of the gate, that provides inherently, because of how it's designed, this notion of location transparency. Those modules all connect to NATs. You apply messaging between them. You don't have to know physically where they're located. So even if they're within the same monolith to start, that's fine. And then you split them all apart and they're distributed. And that's fine too. And they don't have to care. They don't have to know. You don't have to change how you have those modules talk to one another. And I think it's one of those things where you start with a monolith and you're like, all right, I'm using function calls and stuff like that. And then you're like, how do I go distribute it now? You have to completely rewrite all of your logic, all of your communication mechanisms. So it's very painful.
Really painful. But then this is it. You know, like what we need is we need like a real world little robot hand that like pokes you when somebody else is like, hey, I want to interrupt. I've got an idea. Maybe that's a product idea. I don't know. That'd be fun to build. Yeah, I want it like a pin board where I go, right. Mm-hmm. So you said something just, and it's like you go from monolith, you break apart the, whatever you want to call it. You break apart the internal pathways, and then you make those functions effectively available over the network. That's what we're saying. Mm-hmm. But the wonderful thing in that is something somewhere has to orchestrate those function calls. And whether that's a blob of business logic, which might have a larger surface area than some of the other components, that might make 5 calls. It might do data enrichment. There might be a sequential set of calls that thing makes, and then sends back a result or something back to the caller. Excuse me, damn flu. But the smaller those components get, the thing that I find fascinating, that the book has to land somewhere. So in your experience then, is there an optimal way of, or say an optimal size, where we can't shrink down the functions anymore? So I think that there's this whole rule of thumb design stuff. You make a function that does one thing. It's like the Unix design stuff. You're like, let's do that. Make it do one thing really well. Great. So now we have a bunch of distributed network-based functions, and now we've got no way of, or no easy way of tying the logic together. So either, and again, I could be way off with this, but the way I see the world is you generally need a blob of code that's got some of the business logic in, which one calls these functions, makes these remote procedure calls across the network, and then we'll return a blob. Or one of the other patterns is, you might do like sequential, where you actually might pass a payload. So then it's on the fly. So one unit processes some code, it passes it on to the next one, and it's like fire and forget. I've done my bit, throws it to the next one. And I think that scares a lot of people. Then what do? You've made it more complicated. So each developer then has to know about the data that's coming into it and what's expected from either a data enrichment or a routing perspective. So this comes in, honestly, a lot of this stuff kind of like blows my mind. So in networking, we used to do a lot of service steering, and a lot of it was based on VLANs. So you'd have like, one VLAN between an intrusion detection device, and then there'd be like layer 2 forwarding almost. And it was like hardwired forwarding. And there was no way to break out of that bounds. But software in the service mesh space and the microservices doesn't work like that. You can't forward a packet through several touch points for effective conditioning and handling. So to rewind this, set of blatherings and babbling, going from monolith to modular monolith to, macro services to microservices, what would be the first step then in terms of breaking apart the business logic from the downstream functions that are now on the network, without overcomplicating things and scaring developers half to death?
Oh man, there's a lot in there. So the first thing I'm always amused with. I think most people are past it these days, but I was very amused when microservices was all the rage, and people were like, how micro should you be? Like is it numbers of lines of code, or and which is all just wrong. And so I always just go back, and I've mentioned this last episode too, which is like, I think about really bounded context as a unit, to say, here's a domain context, all of the concepts within this ubiquitous language, more formally in DDD parlance. These are all the concepts that represent a unit within your domain, and that whatever you need to, you can have that as one deployable unit. You could choose to break that up as well. So, domain boundary, bounded context does not equate to a single deployable unit either, but that's at least a starting point to say, I could have a macro service, something that's carved off of my monolith. That thing is sort of like its own domain, its own context, and that could be a starting point in saying, okay, can I deploy this thing does it all scale as like one unit to be able to support what it needs to? Or do I now have to actually break this down farther from a deployment standpoint in order to, scale different aspects of that? So that's like one subtle thing. So there's a path forward with that. It's not, you have to figure it out. And over time, you might realize that some part of your system has to scale differently, or you're going to have a quicker development cadence. So decoupling, the business logic, the domain, the business capabilities from the deployment unit, and keeping those as separate dimensions of thought, I think are important. And then so getting to your next part, yeah, this is interesting because it brings me, if you think about, implementing a service, and let's say, even if you have, again, a monolith, and you have a bunch of classes, you're doing, some business processing of some kind. A request comes in, you're doing a bunch of steps, and then you're returning some response. Your service, what you're doing is effectively orchestration. You're orchestrating and calling, a bunch of different things, composing data together, applying conditions, all this kind of stuff. And so you have these other components. So there's typically like the functions or like the business logic that you're calling out to. That's going to be opaque to you. It should be, from your perspective, if, another team's developing that thing, or that's why we have these interfaces across modules. The implementation details of that thing really shouldn't matter from your perspective in terms of the you being the orchestrator. You need to know the data contract. So data and schema is always, at the end of the day, no matter if it's interface calls across within a monolith, or you're doing network calls, data and schema at the end of the day are king and queen. It is what it is. Everything else is really an implementation detail. And so you can choose as a developer to say, I want to be the one to kind of orchestrate, these calls, do the composition. And you could also be the person who is actually implementing the thing behind, those individual function calls that you don't really care. You don't need to do your own external calls. You don't have to call anything else. There's no dependency. Again, those are like terminal functions, for a lack of a better term. And what's interesting, we talked about this the other day, which was this idea, and I would again say it's like, can we abstract this away with Nats a little bit as well? And so if you were to focus strictly on business logic, how far could you go with, and I'm going to rely on you to expand on this too, but how far can you go with saying, I can sort of apply, orchestration more implicitly. And there's a lot of like age-old patterns, as you mentioned, in networking, but also I bring up Gregor Hoppe all the time, but he has this message slip pattern, on the enterprise integration of design patterns, which is this idea that it's just like request comes in, and then you basically have a predetermined workflow, for lack of a better term. And this thing can basically say, hey, hit this function or send it over to this component, get some data back, do some processing, and then it goes on to the next step. You can parallelize these things as well. And yeah, it's effectively the same thing that you're doing, when you're implementing your own service, you're invoking things in a certain order. And I just as a final fun note, and we were laughing about this before the call too, which was, we think about, the drive of programming models to introduce sort of these asynchronous primitives, these async await type of things. And they're like all the rage. And you want to use that within, your program, because you don't have to, callbacks and promises and all those things, at least in the JavaScript land, can be a little painful. With Go, we obviously know we have like Go routines, and you have to make sure you can resynchronize that back to receive like over a channel or something. So there's all these like asynchronous like concepts that people just want to use because it actually it can improve your whole programming model. And then we think about HTTP and service calls between components, and then we're right back into synchrony land. And it's just like an interesting, I don't know, it's a funny thing to think about. Whereas we can, again, break that mindset, think about maybe alternate ways of doing this that doesn't rely on synchronous HTTP. So
yeah, it's kind of hilarious. It's kind of sad in some ways, but it's kind of hilarious. Yeah, let's build some web components, and it's all very asynchronous, and we can have all these random updates. Oh yeah, but wait, we'll just deliver that as one huge HTTP call. Anyway, I'm don't make myself depressed here. I'm just going to take a slurp of coffee. So you made some really good points. I kind of feel unfair here because I hit you with like a world grade question and you answered it beautifully, and it was like 10 questions in one. But if we then think about domain-driven design, so we're talking about microservices, that assumes that your business is of a certain size. You're not just going to do this for the fun of it. You're not going to go from, I've got a Ruby on Rails app, and then overnight go, I'm going to break this apart into 100 functions, because that's kind of suicide for a small business. So let's assume we're at a certain size. So domain-driven design principles are in play. We can say, well, actually, we know the kind of call we need to make to the identity team, the payment provider team, whatever, order fulfillment, that kind of thing. And they're the masters of their own domain. But it still comes down, like you say, to orchestration. You have to orchestrate and coordinate the information that you need. And then either through a service catalog or self-service, kind of schema, you still have to know what team to talk to, what API to talk to, how you access that thing, and get the data that you need. So data schemas, everything. You've got to orchestrate as a designer that thing. And I guess where my brain goes, I kind of go down the entropy level. Every function is available on the network, and it's down to the designers to piece all that crap together and hope for the best. And then it's Wednesday, there's a bug, and you go from whatever 2917 to 2918. Not that those version numbers are important. And that's on net, and all of a sudden stuff breaks. Oh no! Oh hell! But the book has to stop. It's got to stop somewhere. So then, if we think about a proxy landing a call, and that maintains state. So let's say we're not using Quick, we're not using UDP. This is all classic TCP stuff, and it holds a connection open. The next call then might be to the first business blob service, and that might do a database dip, it might do a payment check, whatever, who cares. Let's assume then all those calls are made perfectly. That's hard enough in itself. To do that, to test that, to keep the life cycle, and then respond it's almost like a hub and spoke set of calls. You don't find many, I guess from a tree perspective, you won't find many what's the right word I'm looking for here? Recursions down a tree. You won't find many steps beyond the first set of of calls. Almost like a hub goes to a spoke. Maybe a spoke calls one more spoke in really worst cases. But what I don't see a lot of is
call stack.
Yeah, the call stack's quite shallow. It might be wide, but it's really quite shallow. But we don't see a lot of independent east to west calls being made. So what I mean by that, I'm just going to go through some networking stuff. Not that you need to know this, but anybody in the networking space will understand MPLS. And MPLS, for the most part, I think you can view it in two ways. One, you have the service provider take on MPLS, which is it's a core fundamental technology to ISPs globally. It's how they make their bread and butter money. And then you've got MPLS from an IT administrator point of view, which is a wire. You plug it into your router or router and away you go. But that's not what MPLS is. MPLS is an encoding and encapsulation mechanism. You take a payload, instead of an IP address, you slap an arbitrary number on it. You have a number stack. Different systems have number stacks, they exchange them, and then they pass label information. So I'm going to encode everything coming to me as label 42, and here you go, and passes it downstream, which means it can be done exceptionally quickly in the ASICs. So MPLS is kind of interesting. But then you can do all these things where you can create pathways through the network by label imposition and label swapping, which means if you have a routing protocol and you're looking for the best path through the network, your MPLS network, on the same network, could be doing something absolutely differently. And then you can group nodes together into these labels. So you could have 4 paths available as, label 3 and 4 paths available as label 2. And then you can have shared fate where, if one goes offline, actually, fast reroute to the other. And these things can be done in like sub-millisecond, decision time. And I guess that's exactly, I think, where all the microservices is kind of going. Like we end up with, multiple paths. You can go down, let's say you might have 3 nodes in a database cluster, and any one of those nodes can pick that function call up. But the thing is, it's down to the software developer to make that call to that proxy, and then the proxy figures out what node it's going to call. And I guess the thing that we've been talking about and yammering on around is like, what if that wasn't the case? So let's say before I dive down that whole rabbit hole, which is quite deep, we take NATs and we make NATs pervasive for an organization. So it's in the the payment team, it's in the customer account team, it's in the warehouse and fulfillment. It's even like at the fueling station for the trucks. Everything's tied together, and we can access data ubiquitously across a business. And then from a domain-driven design point of view, we can stand up, say, maybe an inbound subject that accepts a certain schema and payload for that job. So all of a sudden we have this, far edge to front door data system. But then orchestrating calls between subjects is interesting, because either the developer has to understand the subjects to call, or it makes the first call and passes a buck along, and then it just waits for it to come back. That sequential chain versus, I guess, first hop combinatorial.
Yep. And I'm going to throw another term at you. And I think this is this is where the spectrum, and people are like, oh, it's not just orchestration. What about choreography? And this idea, inverting, and I think some people might be dogmatic with that, of saying you have to do one or the other or whatever. It's like, actually, there's a spectrum. And I think it depends on what your component is needing to do. So just for listeners, like choreography is this idea that it's very much event driven, in the sense that, like, let's say a request initiates, something to happen. My service does something. I publish an event to say something happened. And then any listeners, any other components in your system that are interested in that event would be subscribed to it, and they can react as a side effect of that event happening. And then in turn, they might raise an event, so on and so forth. And that is a beautiful way to decouple components from a function invocation standpoint. It still couples on the data side. Going back to schema and data, you can't get around that. If you publish an event and you change the schema, and downstream subscribers don't understand that anymore, that's a problem, right? So there's still going to be data contracts that have to be coordinated in some form or fashion. But you were talking about teams and separate domains, separate bounded context, things like that. That's a great way to say, hey, asynchronously, raise this event. Well, how do you do that with HTTP? You can't. Yeah. You can't broadcast. You can't do any of that. It's like, who am I sending the request to? You have to explicitly know, who you would be sending that message to. So what do people do? They need a message broker, or they need, some streaming system. They use SQS, whatever. And it's just like, well, Nats, supports both of these things natively. You can say, I can do request reply. I can do request reply many, because it can do pub sub. It's broadcast, and you can wait for n number of replies based on what you expect back. You can publish fire and forget, and whoever is connected at that time will receive that message. Maybe it's a time sensitive event, so you don't want to store it later and then pick it up later. And then you also have persistent streams, so you can publish a message, and when the consumers are ready, they can dequeue it and process it when they're online. So it's going back to this idea of like having a spectrum of communication patterns, both synchronous, asynchronous, being able to sort of, have your components talk to one another, and not being constrained to purely a, synchronous call between components. So you can choose to be that orchestrator. Your component might have to be synchronously calling a database or doing some other IO, but with respect of that component to the rest of your system, you could say, hey, I just want to publish an event when this happens, and I don't want to actually need or know to care which other components are actually interested. So you have that choice, which I think is the key thing here.
I was going to pin you there as well. You man, these conversations always do this. My kind of brain goes off. It's like blunderbuss shot off the hip. So going back to the whole coordinated and kind of choreographed, or you could guess, like it's centrally coordinated or decentralized and self-organizing. One of the things, one of the patterns I've been thinking about a lot is if you had like a front door proxy and it's got a bunch of filters and it says, oh, hey, I've had a request through to this, whatever, to this API endpoint, and my downstream systems have got to be, whatever, version 2.1 of the schema. The problem is, what do? Do you choreograph the lookups? So you have a lookup table and you go, those nodes are the one that can satisfy this version of my current API, like A/B testing. Or flip it round. What if you put the required version in the header on a NAT subject? So you literally just pub it to a subject, and then you do a scatter and gather response. You literally listen for responses coming back, and you've already told the group of listeners what I'm interested in as a response. And that's a nice way of doing that. So A/B testing means you stand up a new service, you subscribe to the same subject, and then you just listen for the headers. And we're talking about headers here. Headers aren't anything special. It's just an arbitrary bunch of data you can send into a message. But you can use them, I think, for this pattern really, really quite nicely.
Yeah, absolutely. And I think that's one of the things, going back to HTTP, again, there's a lot of good, patterns and headers and semantics that these HTTP specs have accrued over time. I think content types, and like encoding, saying, what is the body of the message, and using that metadata to be able to understand. It could be a schema, it could be the serialization type, all that stuff you can apply the same way in a NATS message, and so but the kicker, as you said, you can do scatter and gather, you can broadcast it out. You're not limited to knowing ahead of time of like who am I able to talk to. And even things like service discovery, where you're like, well, you can have multiple instances of this thing, they can all be registered, but you still are limited to talking to one component at a time. You'd have to, do the coordination of saying, how do I apply scatter and gather from your service? And that just kind of comes for free for NATS, which is nice. Yeah, so I think just to I think wrap up that bit and getting back to your entry point into that, let's say that proxy. Now you have that choice of saying, being able to apply the orchestration or the choreography approach, and using message headers and things like that, and tokens in a subject to be more or less granular about who should be listening to those things. Because you can even apply, a V1, V2, Vx in the subject itself. And so you can explicitly say, I only want, service responders that are subscribed to this version of this endpoint explicitly. Or you can say, I want to be a little bit more permissive and say, I'm not going to include the version in my subject, but I will indicate in the header, right? And so you have that flexibility.
Yeah, I guess this is something that Joe Armstrong used to bang on a lot about, what it was, accept liberally but send conservatively. And I know he had all sorts of beef with that particular problem, which was hilarious. But I think we could do that. If you keep subjects very liberal in terms of their loose description and you make those available cross-team, then you can stand services up based on header information. And you can dictate what responses you're likely to get back. And I think that's really quite something, because you don't need the coordination step. And when you're building systems, it's one lookup you don't need. And great lengths are gone to, like in the networking space, to reduce the number of lookups. Like lookup trees are incredibly optimized to just make it a single pass look through. And I think the problem is in software, we kind of go, hey, we just throw some more CPU at it. It's fine. But what if we didn't? And then it adds fragility. What if that version of the API has been made redundant? Oh dear. Now we've got to go off and change some definitions on another proxy somewhere else. But as we come upon, I guess, maybe time for this episode, I want to plant a seed. And to take that HTTP hammer away from developers and say, okay, let's talk about the modern world that we're in. This is a thing I find absolutely fascinating. If you flatten the means of inter-system or even intra-system communication. And again, we're going to say this because we're all about NATS. but you have the front end NATS client and you've got your back end NATS clients. Providing your authentication mechanism can give you access to the NATS system, the NATS architecture. There's no reason why you can just abandon HTTP altogether. And that's the thing I find beautiful. You don't need to rely on these typical semantics anymore. You could take NATS all the way to the front end. And maybe the only time you use REST, or hell, I've done that crime there. REST or HTTP, shoot me later. It's maybe at the point of authentication with your whatever authentication provider. Log in, take the old path, and then once you're on the system, you've got access to the various domains and the services that your business domains offer you. I think that's really something quite nicely. And I'd love in another episode just to go over some of the source routing stuff. I think you see Gregor Hope calls it like the slips. Source routing in networking, message slips in messaging. I think we could explore that one a lot deeper.
Yeah, that sounds great.
Cool. So, knowledge nuggets. Anything you want to leave for episode 3?
I think leading into it, just take a step back and say, if I didn't have HTTP, if I didn't have gRPC included, and we didn't even touch on that too much, what could the world look like if I had, a richer set of communications, no dependencies on all of these, service discovery and proxy sidecars and things of that nature. And we'll likely touch on service mesh more explicitly next episode. But yeah, it's going from that journey of monolith to modular monolith to, your first extra service and how do they communicate and, what's the contract between them and is it synchronous, asynchronous, things like that. It's good to think about and not to keep yourself in this mold of, synchronous point-to-point HTTP calls.
Yep, good wisdom. Yeah, I think I'll just add on, try and remove lookups. One step at a time. Remove the fragility by removing choice. Allow the system to self-organize. I think that's one of the wonderful things that NATS brings to the table, amongst others. So there we go for episode 3. I think, as always, thank you for this, Byron. It's always a pleasure to do these. And to our listeners, thank you for listening. If you like this episode, if you're looking on YouTube or watching on YouTube, please hit like and subscribe, or on your favorite podcatcher, maybe like and subscribe on that. We'll catch you next time. If you have any ideas for topics you'd like on an episode, come and join us on the NATS Slack, and you can catch me or Byron on there. We can talk about this as well. So thank you as always, and we'll catch you for episode 4.